three operations. One is curl, second one divergence, third one is gradient. So now we are going to study about gradient. So gradient of a scalar field. Gradient means we will use this notations del f, del or it is called as nabla. Del f or gradient f. So here we are using 3-dimension Cartesian coordinate system. Totally we have 3 coordinate system. One is Cartesian, another one is cylindrical, third one is spherical. So now we are using Cartesian coordinate system. For coordinates x, y, z we will be using it. So here we have grade f or del f. So we have written del f is equal to I dou f by dou x plus dou f by dou y plus k dou f by dou z. So for Cartesian coordinate system we are using x, y, z. Cartesian or rectangular coordinate system. X, y, z. So I, j, k. It may be written as ax, ay, az in. So you can refer some other books for ijk or ax, ay, az. So here pi is equal to x square y z cube plus x y square z square. Determine grade pi at point P 1, 3, 2. So pi is given x square y z cube plus x y square z square. So you can refer this question. Now we are going to calculate for grade pi. Grade pi means we will use dou pi by dou x, dou pi by dou y and dou pi by dou z. So instead of f you can refer this question. Pi is given, so you have to calculate for dou pi by dou x is equal to 2xy z cube plus y square z square. So you can differentiate once with respect to x, you will get 2x y z cube, here y square and z square. So dou pi by dou y x square z cube plus x z square into 2xy z square. For z, x square y into 3z square, x y square 2z. So 2z x y square. So dou pi by dou x, dou pi by dou y, dou pi by dou z is written here. So del pi is equal to dou pi by dou x I, dou pi by dou y j, dou pi by dou z k. So here 2xy z cube plus y square z square. Here x square z cube plus 2xy z square j, 3x square y z square plus 2xy square k. So at point P 1, 3, 2, del pi is equal to x is equal to 1, y is equal to 3 and z is equal to 2 is applied. Here 2 into 1 into 3 into 2 cube. Here 3 square into 2 square. Here 1 square and 2 cube. So we have to substitute the values for x, y, z. So here we will get del pi is equal to 84i plus 32j plus 72k. So this is for gradient pi. So you can use any it may be ijk coordinates or ax, ay, az or simply x vector, y vector, z vector for coordinate system. So you can use anything instead of ijk. So for gradient property, del a plus or minus b is equal to del a plus or minus del b. Del ab is equal to a del b plus b del a. Directional derivative of pi in the direction of a. d pi by ds is equal to a gradient pi. A means unit vector. Unit vector is defined as the ratio of any vector by its magnitude. If any vector is given, for example 2i plus 3j plus 4k is given, we have to write the vector in the numerator and we will take 2 square plus 3 square plus 4 square, root of 2 square plus 3 square plus 4 square in the denominator. So we will get unit vector. So unit vector in the direction of dr. So here ratio of any vector by its magnitude is called unit vector. So compute the directional derivative of pi at the point 1, 2, minus 1 in the direction of a vector a is equal to 2i plus 3j minus 4k. So directional derivative we are going to calculate create pi. So create pi already we have calculated in the previous question. So pi is given. So dou pi by dou xi plus dou pi by dou yj plus dou pi by dou zk. So for pi we can substitute x square z plus 2x y square plus yz square pi del pi equal to 2x z plus 2y square into I 4. So differentiate with respect to y, we will get 4xy plus z square j and x square 2yz k. So we can apply this value 1, 2, minus 1. Then we will get del pi equal to 6i 2 into 1 into minus 1 2 into 2 square. Here 4 into 1 into 2. Here minus 1 square. Here 1 square. Here 2 into minus 1. So del pi is equal to 6i plus 9j minus 3k. This is for del pi or gradient pi. So vector is vector we have calculated the vector 6i plus 9j minus 3k. If you refer this A is given 2i plus 3j minus 4k. So vector is given. We can take the magnitude of the vector root of 2 square plus 3 square plus minus 4 square. We will get root of 29. So any vector by its magnitude, this vector 2i plus 3j minus 4k divided by root of 29. So we will get d pi by ds is equal to a gradient pi. So we can multiply this a and gradient pi. We will get 51 divided by root of 29. So for this we have to refer I dot I is equal to 1, j dot j is equal to 1 and k dot k equal to 1. If I dot j is multiplied, alternate vectors I dot j or j dot k dot I is equal to 0. So del operator dou by dou x ax, dou by dou y ay, dou by dou z az. This is for Cartesian coordinate system. We have already studied. I have explained here x y z is Cartesian coordinate system. If you refer two more coordinate system, one is cylindrical, another one is spherical. So we can write this equation del for cylindrical coordinate system with coordinates. Here x y z is written. For cylindrical we have to use rho pi z. For rho we have to write dou pi dou rho a rho and 1 by rho dou by dou pi a pi plus dou by dou z a z. This is for cylindrical coordinate system. Then next for spherical coordinate system we will use so here we are using xyz for Cartesian coordinate system. Cylindrical we can use rho pi z. For spherical we will use r, theta and pi. Sometimes this rho can be replaced with rho pi z. Instead of rho, sometimes in some other books it has written r pi z. If r pi z and r theta pi is coming, means first we have to refer this rho pi z. If it is coming with pi z, then we have to take this is for cylindrical coordinate system. So rho pi z. If it is coming with theta r theta phi, then we have to take spherical coordinate system. So this is for del operator ax ay az Cartesian, rho pi z cylindrical, r theta pi spherical. So here we are writing dou by dou rho 1 by dou dou by dou pi, 1 by rho dou pi a pi plus dou by dou z a z for cylindrical. If we refer spherical, we'll get del dou by dou r a r plus 1 by r dou by dou theta a theta plus 1 by r sin theta dou by dou pi a pi. So this one for spherical coordinate system. Now we are going to write gradient for remaining two coordinate system. So gradient pi or gradient v or del v, both are same. So here we are using this notation v for vector. So grad v is equal to del v. So dou v by dou x ax plus dou v by dou y ay plus dou v by dou z az. This is for Cartesian coordinate system. If it is cylindrical coordinate system, you can use rho pi z. So dou v by dou rho a rho, dou v by dou pi a pi, dou v by dou z a z. In cylindrical coordinate system, we have to use this rho over here. For spherical coordinate system, gradient pi is equal to del v. Gradient v is equal to del v dou v by dou r a r plus 1 by r dou v by dou theta a theta plus 1 by r sin theta dou v by dou pi a pi. So here we are using x y z coordinates. Here rho pi is z coordinate and r theta pi coordinate for spherical coordinate system. So here we have to take 1 by r, 1 by r sin theta, here 1 by rho. That's all about gradient of scalar field. So same thing written here for cylindrical coordinate system, rho pi z, and spherical coordinate system. So this for gradient of Cartesian, cylindrical and spherical. Now we are going to solve this problem for find gradient of this scalar. V is equal to e minus z sin 2x and cos ho is given. So first is we have to take this v. Now we are going to calculate for gradient. If you refer this equation, you have x y z coordinate system. So we have to write gradient equation del v for del v is equal to dou v by dou x ax, dou v by dou y ay and dou v by dou z az. Just to substitute this v in gradient equation, we will get dou v by dou x, dou v by dou y and dou v by dou z. So we have to substitute this equation in v, dou v by dou x ax, dou v by dou y ay, dou v by dou z az. So del v is equal to dou v by dou x ax plus dou v by dou y ay plus dou v by dou z az. V is equal to e power minus z sin 2x cos hy. So we can differentiate once with respect to x. So e power minus z and cos hy can be written here, remaining sin 2x. So sin 2x is differentiated, we will get 2 cos 2x ax. The next step, we have to differentiate with respect to y. So for y, e power minus z sin 2x is written, e power minus z and sin 2x is written. We have to differentiate only cos hy. So cos hy, differentiation of cos hy is sin hy. So we have written here. The third step, we are going to differentiate with respect to z. So remaining two terms, sin 2x and cos hy. Sin 2x and cos hy is written here. For e power minus z, differentiate once with respect to z, you will get minus e power minus z az. So this is for gradient v x y z. Now we are going to write gradient for rho pi z. So rho pi z means cylindrical coordinate system. So for cylindrical coordinate system, we have to write dou v by dou rho a rho, 1 by rho, dou v by dou pi a pi, dou v by dou z az. So we can differentiate once with respect to rho square z cos 2 pi. So for rho, 2 rho z cos 2 pi. So 2 rho z cos 2 pi. In second step, we will differentiate with respect to pi. So rho square z will be written as it is, rho square z. So rho square is it cos 2 pi only differentiated. If you refer this equation, we have 1 by rho dou v by dou pi. So one rho will get cancelled here 1 by rho we have written dou v by dou pi. So rho square is it cos 2 pi. So rho square is it cos 2 pi, rho and rho will get cancelled, remaining we will have only one rho. Rho is it cos 2 pi is equal to minus sin 2 pi into 2. The next step, rho square cos 2 pi. For z, we have z, so you can differentiate once with respect to z, absolutely 1. So rho square cos 2 pi az. This is for cylindrical coordinate system. Now we are going to solve problem for a spherical coordinate system. Tell w is equal to dou w by dou r ar plus 1 by r, dou w by dou theta a theta plus 1 by r sin theta, dou w by dou pi a pi. So we can differentiate once with respect to r. We will get 10 sin square theta cos pi, 10 sin square theta cos pi as it is, then differentiate with respect to r, so equal to 1. The next 1 by r, differentiate with respect to theta, we will get 10 r sin square theta cos pi, 10 r cos pi sin square theta. So for sin square theta, we will get differentiate with respect to theta. So sin square theta we have to differentiate. We will get sin 2 theta cos pi a theta. The next one 1 by r sin theta dou w by dou pi. So it can be multiplied with 1 by r sin theta. So differentiate third equation by pi. So 10 r sin square theta, 10 r sin square theta, differentiate with respect to pi. So cos pi will be written as minus sin pi. So this is for gradient. The next one is curl. In vector calculus, the curl is a vector operator that describes infinitesimal rotation of a 3-dimensional vector field. So here we are going to use for curl a del cross. We will use this symbol del cross A. So this is for curl. So curl of a vector ai, aj, ak, curl is given del cross A. So for del dou by dou xi, dou by dou yj and dou by dou zk is written. A is given ai plus aj, ayj and azk is given. Just we have to multiply this two. This operation is called curl. So curl A is equal to ijk dou by dou x, dou by dou y, dou by dou z. Ax, ay, az is given for curl A. ijk dou by dou x, dou by dou y, dou by dou z. Ax, ay, az. Curl of a vector f is another vector ijk dou by dou x, dou by dou y, dou by dou z. f1, f2, f3 is given. Just to cross multiply this and write the equation I dou by dou y f3 minus dou by dou z f2. Then for j minus j dou by dou x f3 minus dou by dou z f1. Likewise k dou by dou x f3 minus dou by dou z f1. So this is for curl. Curl f is equal to 0, then it is called a rotational vector. So f is irrotational, then there exists a scalar point function pi. F is equal to del pi. Pi is called scalar potential. Curl signifies the angular velocity or rotation of the body. So here we can write this curl. If a curl is given means we have to write first, we have to form matrix IGK dou by dou x dou by dou z dou by dou y. Sometimes in vector itself it may be given ax, ay, az for coordinates. So ax, ay, az dou by dou x dou by dou y dou by dou z, and the coefficient we have to write coefficient in the third row. So curl f is equal to 0, then it is called a rotational vector. So curl of a vector means curl A equal to del cross A, limit del s tends to 0, A dot dl by del s. This is for curl of a vector. So you can calculate curl A is equal to del cross A ijk dou by dou x dou by dou y dou by dou z. So this equation can be written y4 minus x square z square and x square plus y square minus x square yz. So you can multiply this equation by dou by dou z minus x square yz. So you have to differentiate once with respect to y. Then here x square and x square plus y square. So differentiate once with respect to z. Anyway this term is going to be 0. Only we have to take this equation. So minus x square z into I for first step. Second step dou by dou x minus x square yz. So we will get minus 2x yz, and here also we have to multiply and differentiate once with respect to z. Third one, differentiate once with respect to x and differentiate once with respect to y, and substitute the values for x, y, z. X is equal to 1, y is equal to 3 and z is equal to minus 2. Then we will get curl. Curl is equal to 2i minus 8j minus 106k. So this is from curl A. So for curl we are using 3 coordinate system: Cartesian coordinates, cylindrical and spherical coordinate system. So ax, ay, az dou by dou x dou by dou y dou by dou z. Ax, ay, az coefficients are given. So here in cylindrical coordinate system we will use rho pi z, and spherical coordinate system we will use r theta pi. So you have to mug up these equations and matrix